Here is a bunch of photos. It is very choppy, not great to look at. And now, hold on to your papers, fellow scholars, and check this out. Whoa! What happened? Did we just take a video, that is this one, and take out a few images to make it look choppy? Nope. Exactly the other way around. This is an AI-based technique that looks at a bunch of photos and learns the world from these photos. So much so that it is able to synthesize what is in between these photos. Magic. Absolutely incredible. Scientists call it NERF. These are amazing for training self-driving cars in a virtual world, creating movies, video games, and more. These would be amazing if it worked, but it doesn't. You see, NERFs are not new. Previous techniques were able to do this kind of thing, but look. This was the quality that was possible before. Ooh. Do you see those floaters? They are kind of ruining the whole scene. Why did they appear? Well, imagine trying to buy a house. Well, let's be honest here. Based on how the economy looks today, that's probably the closest any of us is getting to buying a house. Alright, so you go and check the house on Monday. It's a blue house. Then you go check again on Tuesday and it is fiery red. What is going on? Then on Wednesday, dark and shadowy. And understandably, you get quite confused. What happened? Is this some sort of magic house? Is this why a tiny shoebox costs more than $1 million in California? Karoly, come on. Okay. So then you realize it's not magic. It's just a normal house. But each day you showed up with a different pair of sunglasses. Now that is the exact problem we have in 3D reconstruction today. We take thousands of photos of a scene, but each photo is a bit different. We get them from a different time of day, from different angles, but it gets even worse. Cameras choose a bunch of parameters like exposure automatically based on how much light they see. This can change a lot from one frame to the next. That leads to a disaster. Why? Because the reconstruction algorithms think that the objects are suddenly changing color. They really think that this house is blue on Monday and red on Tuesday. And yes, this is what creates the floater problem. We get ghostly 3D models because the AI tries to paint these lighting errors onto the 3D object itself. The result is this blurry nightmare. Now, enter NVIDIA's new technique called PPISP. This is a master detective who says, I am not going to look at the house. I am going to meet the buyers and look at their sunglasses instead. Genius. It actually understands what the house looks like. And the result? Yep, the ghostly floaters are finally gone. Hey! Okay, so how do they do that? Well, the master detective shows up and looks at the first photo. He finds that the exposure and the white balance values are weird. Now he says, okay, this buyer is wearing blue colored glasses and they are standing in a dark spot. And here comes the magic part. He now surgically removes the blue tint and the darkness to reveal the true color of the wall. Oh yes! Then, when a new video is created, you are actually seeing reality. And then, you can choose what colored sunglasses you want to use, if any. Here you can see how it is predicting different exposure and color correction values for each frame. This is super tough because you have to do it in a way that gives you a convincing video where the colors don't start flashing like crazy from frame to frame. The mathematical tool that the master detective is using is called color correction matrix. It sounds amazing, but all this means is a 3x3 grid that is the prescription for your sunglasses. It tells you how the colors were changed by the sunglasses, the camera that is. By solving for this matrix, this can revert colors back to reality. Absolutely amazing. So, would you like to see the master at work? Look, this is going to be incredible. Watch how it peels the layers off the image one by one. First, it solves the exposure offset. basically figuring out how bright the scene was. Then it figures out the white balance, removing those colored sunglasses. But here is the most impressive part. Look at the corners, it learns the vignetting effect too. You see, real camera lenses are imperfect. They make the image darker near the edges. The AI learned this behavior of the physical lens just by looking at the photos. It's like it reverse engineered the camera that took the picture. That is insane. And finally, it solves the camera response curve. Digital sensors distort light in a weird, non-linear way. The AI figured out that distortion curve and flattened it out. And now, by solving these 4 specific puzzles separately, it doesn't just paint a pretty picture. It mathematically reconstructs the reality that was hiding behind the camera's messy lens. Now, here's something wild that I realized. The controller they built, this is the thing that fixes the exposure for new views. This works almost exactly like the auto exposure system in your smartphone cameras. Yes, they essentially reinvented the digital camera's brain inside a neural network. That is kind of genius. But it is still not perfect. I'll tell you why in a moment. But there is more to be learned from this paper. For instance, remember that the AI separates the object's true color from the camera's biased image. This is great life advice. Separate facts from your feelings. Don't confuse a bad mood with a bad life. Then, the AI learns the flaws of the camera to correct the final image. You can do that too. Try to find your own biases and try to correct them. Acknowledging your flaws is the only way to see the world clearly. So cool. This work is coming from a team of scientists at NVIDIA who are known to do great computational photography work. And they took this amazing piece of work and gave it to all of us for free. Thank you so much. This is a great gift to humanity. What a time to be alive! Now, not even this technique is perfect. Even the master detective has its limits. So, what are the limits? Dear fellow scholars, this is 2-minute papers with Dr. Károly Zsolnai Fehér. Wow, that was a long cold open. Now, the paper mentions that the method ignores spatially adaptive effects. Okay, what does that mean? Well, our master detective assumes that the camera follows strict global rules. Uh-oh. But modern smartphone cameras are sneaky. They use techniques to brighten just a face or darken just a bright window. This is called local tone mapping. These tricks break the global rules, and when the detective sees these, he gets confused because they don't fit his physical equations. He thinks the whole room should be bright, not just the window. So, a really advanced paper explained in simple words. Hope you enjoyed it. If you did, consider subscribing and hitting the bell icon. It would be great because there is doom and gloom everywhere you look. And so few people are talking about these amazing works of human brilliance. More people need to hear about this. So, save the snails, save the beavers. Subscribe to 2-minute papers. Here you see me running the full DeepSeek AI model through Lambda GPU cloud. 671 billion parameters, running super fast and super reliably. This is insane. I love it, and I use it on a regular basis. Lambda provides you with powerful NVIDIA GPUs to run your own chatbots and experiments. Seriously, try it out now at lambda.ai/papers or click the link in the description.